Okay, guys, we're going to be working on, wrong lesson, 9.4, a new technique on how to solve quadratic functions. Solving quadratic, if I could spell today, quadratic functions by completing the square. Now, this technique is not one I tend to use. However, it becomes necessary to use something, this one or something else we're going to talk about on Thursday, Friday, when I can't play the game, when the game doesn't allow me to play. So, we're going to take a definition of completing the square, and then we'll kind of go through the steps as we solve a problem. So, completing the square. So this is a process where part of a quadratic function, the ax squared plus bx section, can be transformed into a trinomial square. Okay, so we're going to use this idea of completing the square in conjunction with that square root property, where we create something that's squared equal to a number, and then we can take the square root of both sides and solve it from there. Okay, so we may get answers that work out beautifully, or we may get answers that have a radical as part of them, and we saw some of those in our homework. So let's talk about the steps to complete a square, or the square. So I'm gonna, over on the right side, I'm going to write an equation we're going to start this with, and let's see, let's do x squared minus 6x plus 12 equals 19. Okay, so to complete the square, the first thing I want to do with these equations is to make sure that we only have the quadratic and linear terms alone on the left, and then everything else on the right. So we're going to subtract the c value from both sides of the equation. So for us, we would subtract 12 from both sides. Now, if we try to complete the square and we end up with a negative number on the other side, then we're kind of sunk. Can't do anything with that. So right now, we just have x squared minus 6x, that's a terrible equal sign, equals 7. Okay. Next, we're going to take the linear coefficient, and remember that's the b value, and cut it in half. Now you might say, wait a second, why would we do that? Well, remember, have a trinomial square, the linear coefficient is the result of adding the same middle term together. So two middle terms, add them together. So that number represents two values that are identical being added together. So if we cut it in half, then we're going to figure out what we have. Now, I'm just looking at the coefficient. I am not paying attention to the variable at this point, okay? Next, we're going to square the halved b value. So for us, we're going to take 3 and we square it and we get 9. We're going to add this value to both sides of the equation. So remember, our equation look like x squared minus 6x and then equals 7. And we are going to add 9 to both sides. Oops. Then we're going to factor the trinomial square, because that's what we've just created. And remember, we're going to take that linear term, we cut it in half. Okay, or we can think about square root of the first term is x, square root of the second term is 3, middle is negative. And then on the other side, we're going to just add up, simplify it. And then we're going to do take the square root of both sides. Then solve for the variable. So we should get 2 answers. Okay. So remember, we're going to take this guy. X minus 3 squared equals 16. We're going to take the square root of the left side. We need to put plus or minus in front of the other side because I just took the square root of a variable, and I don't know whether it's the positive version of it or the negative version of it. So when I take the square root, I get x minus 3. The square root of a quantity squared is the quantity, equals plus or minus, and the square root of 16 is 4. I'm going to add 3 to both sides, and I get x equals 3 plus or minus 4. And then I'm going to do the 2 cases. So x is going to be 3 plus 4, or 7. Or x is going to be 3 minus 4, or negative 1. Okay, and then I can always test that to see in the original equation, see if it works. So that's 49 minus 42 is 6. 6 plus 12 is, no, is that right? 42. 6 times 7 is 42. 42 from 49 is 47. Is 7. 7 plus 12 is 19. Phew. I can do math. You're right. And then negative 1 squared is 1. Negative 6 times negative 1 is positive 6. So we're going to get 18, and negative 1, or positive 1, is going to give me 19. So yes, they both work. So the solution set, I'll put it up here, would contain 7 and negative 1. Okay? So let's go to the next, and we'll do just a couple of problems. So some of the things you might be asked to do is just complete the square, not figure out what the answer is, but just complete the square. Complete the square, and that means find the value of c. That's from your standard form. That makes the trinomial. Oh, hello. Let's try that again. that makes the trinomial a perfect square trinomial. So this is its other name, trinomial square, perfect square trinomial. Okay, so first problem, we've got x squared plus 4x plus c. So what we're basically going to do is, I'm going to go back to the other screen, we're going to do step 1. In fact, we're just going to, actually, I'm not even sure we'll have a c, so we might not even have to do, we won't do that because it's not there. We're going to start at step 2. We'll take the linear coefficient b, cut it in half, square the halved b value, and then we're going to put it back into the equation, and then we can even verify that we could factor it, okay? Excuse me. So we want to figure out what c is going to be so that we have a perfect square trinomial. So first thing we're going to do is take the linear coefficient, we're going to cut it in half, and that gives us 2. Then it says go ahead and square it, and that equals 4. That's what we're going to replace the c with. So then we would have, I don't know why I put parentheses, we have x squared plus 4x plus 4. So we'll double check that it's a trinomial square. I can take the square root of the first term. I have a plus in front of my third term. Square root of the c value is 2. If I multiply those and double them, do I get the middle term? And the answer is yes, I do. So I take square root, sine of the middle, square root, into a binomial, and squared, since it'd be the same binomial twice. Okay, so awesome sauce, it worked. All right, let's try another problem. Another one of these. We have r squared minus 8r plus c. So again, we're trying to figure out what to replace the c with. So we're going to take the linear coefficient. Don't worry about signs. Signs aren't going to play a role here. Cut it in half. We get 4. Then we're going to square that halved b value, and then that's going to replace the c. So we'll test. We have r squared minus 8r plus 16. So let's see if it meets the condition of a trinomial square. I can take the square root of the first term. I have a positive third term. I can take the square root of the third term. If I double those, or I multiply those two terms and then double the answer, do I get the middle term? And again, signs aren't important. The answer is yes. So then all I do is I grab square root, sine of the linear term, square root, and then that forms my binomial, and then it's squared. And again, you can go ahead and multiply it out. So again, I guess I should start this guy. So this is what I created that was a trinomial square. All right, let's do one more problem, and then we'll be done for today. So this one's going to be doing the whole thing and solving. So let's say we have negative 2x squared plus 8x minus 18 equals 0. So we haven't dealt with this before. So here's a problem. Forgot to mention this. You need to have a perfect square in front. So if your a coefficient isn't a perfect square, so I'm going to write a little note. If a doesn't equal a perfect square, then you're going to get rid of it. How? You're going to then divide all terms by the a value. Okay? So for us, we're going to divide everything not just by 2, but by the -2. Now, this is going to go away, and that will leave me with x squared minus 4x, and then plus 9 equals 0. Okay, so now we follow all the steps from the first page. I'm going to go ahead and subtract 9 from both sides. That's going to give me x squared minus 4x equals -9. Then I'm going to take the linear coefficient. I don't worry about signs. I'm going to cut it in half. And then I'm going to square it. We're going to add that in 2 locations. To the end of the binomial to make it a trinomial, and on the other side as well. So then we get x squared minus 4x plus 4 equals -5. Now, I can factor the other side, and we'll just double check it real fast. Square root of x squared is x. Square root of 4 is 2. It's positive. If I multiply those and double it, I get 4x, and that matches. So I'm going to continue the problem off to the side. So we're going to take these 3 pieces to make my binomial. And then we're going to take the square root of both sides. Now you may have noticed something that I haven't talked about yet, but we'll get to it. So this gives me the square root of the quantity squared is the quantity. Okay. And then you should see this issue here. You can't take the square root of a negative number in the real number system. And like I mentioned in class, there is a whole nother system you get to learn about that is not real. These numbers don't actually exist. So the world is called imaginary numbers. So it's theoretical. Well, what if we could take the square root of -5? So you get to learn all about that down the line. So we would say to this problem, my final answer would be no solution in the real number system. It was too bad because it was looking really good there for a while. System. Okay, so anytime you get a square root of a negative, there's nothing more you could do. Okay? All right. That's it. Good luck with this, guys. Bye now.